All right, welcome back. This is going to be start of a video or maybe one or two where we're going to sort of step back and from all the technical mumbo jumbo that we've been doing. Um, we'll be doing some some relevant things, proof based concepts, things like that. But we open up here. I mean, see, we got variables. One. Oh no, is variable? Yeah, it's probably doing it. There you go. Anyway, we got a million videos on variables. Or 16. So we're gonna first thing I'm gonna do is I'm gonna start changing the name of these, and these the titles here reflect the titles on YouTube. So do they have to? No, but I'm making them be that way. So anyway, we're gonna we've talked a lot about variables, a ridiculous amount about variables, and we've been talking about we've been sort of harping on that because it's a really basic concept, and to use a cheat engine in a effective way, you need to. It's one of the basic things you need to understand. So anyway, that being said, the next this video, and maybe if we can't cover it all, then we'll go into the next one or two. But I say video, but it's really a screencast. But whatever, I'm gonna keep calling it video. We're gonna do some goofy things. Does that mean that we're gonna sit down and write a comedy script? No. Are we gonna go tell jokes at the giggle pit? No. Um, a little list here. We're gonna talk about John McCarthy and memory garbage collection a little bit. That'll be a little abstract. We're gonna be clicking around, read some things, making some comments. Next thing we're gonna do is we're gonna crash shadow run. Shouldn't be too hard. We'll just start throwing random values into random memory locations, and any good application that has sanity checks. And well, we're just gonna say that pretty much any application would crash when you start doing that. We've alluded to the fact that oh, you don't want to do this, you don't want to do that because you'll crash your application. But we've never actually crashed the application. We've seen some somewhat spurious results, is what I would say. But they've always been values that we could explain, such as the wraparound and things like that. Um, then I'll sort of segue into this is not a formal lecture series. This is not a substitute for going to college, taking actual courses in these concepts because, are we explaining them? Yep. Or at least I think we're explaining them. Some people may disagree with that, but we are explaining these concepts, we're illustrating these concepts, we're demonstrating these concepts, but it is absolutely no substitute for formal education in computer science or any related field that we happen to touch on. So, you're watching this, you're learning some stuff, doing some stuff, you're feeling good about it. But again, this is not a formal lecture series, and if you go to college or something and you walk into a classroom and start regurgitating some of this stuff, uh, people are professors mostly will first of all, where the hell are you hearing this, and second of all, just university courses are paced, especially not especially, but computer science courses in general are paced in a way so that you can introduce concepts, and obviously you can build on those concepts and out into more advanced stuff, and that's not specific to computer science. That's just inherent in sort of the educational system in this country, which is the U.S. In this country in general. So, yeah, I'll talk more about that in a minute. So, anyway, we'll minimize all this stuff. We got some new wallpaper. What do we got? We have this very serious-looking fellow, and it's sort of a internet thing, and it has programming. You're doing it completely wrong. That's very funny. Why is it funny? We'll talk about why it's funny, and it may not be funny because we have to explain it. It's one of those you have to sort of be there kind of things. But anyway, this gentleman here is John McCarthy, and he is known as someone who is involved in the creation of a programming language called Lisp. And let's see if we can type his name in properly here. John McCarthy, computer scientist. See what it says. It's unfortunately that he passed away. Here's a somewhat more recent picture of him. Again, looking serious, probably telling someone that they're doing something wrong. He was a computer scientist and a cognitive scientist involved in artificial intelligence, developed a Lisp programming language, significantly influenced the design of the Algol programming language, time sharing, more AI, Turing Award, other prizes. Incredibly smart individual. let's click on Lisp. Let's see why. Let's see if we can figure out why this is funny. Let's see, Lisp is a programming language. It's a long history and fully parenthesized Polish prefix notation. It's not important what that is. See if maybe we can. Wikipedia um, occasionally has a sense of humor. See if we can maybe. I don't know. All right, so Wikipedia is not going to do us any favors in explaining why this is funny, but basically, if we were going to talk about why this picture is funny, it's because Lisp is, maybe not so much nowadays. There's many other languages that follow the same sort of paradigm that Lisp does, but when Lisp was first introduced in functional programming in general and things like that started to come around, high-level programming languages, Fortran, blah 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 blah, number of dialects. See if we have. Anyway, you could go to Wikipedia and look up functional programming and what that sort of stuff is. It's actually linked right here. Functional programming. You could just click that. There's the page. You could read about it, but we're not going to do that. Anyway, when Lisp was first introduced, it was a radical departure from the way that programming was sort of done, or at least the way that you express concepts of programming. And so people looked at it with a right amount, or with a proper, and we mean that in the British term, and with a proper amount of suspicion. And so there is kind of a running joke in the computer field, or the computer science field more specifically, that um, you know when when you do programming in the more popular, well-known languages like C, C++, things like that, even Python, which we're using in this series to demonstrate some concepts, you're approaching it in a sort of a basic way, kind of what's known as procedural. C++ and Python certainly don't fall into that strictly procedural category, but for the purposes of this video, what we'll be doing is classified as procedural programming, more or less. Lisp totally takes that, pretty much throws it out the window, and adopts a much more, again, functional style of programming. We're not going to dive into any of that, but so again, they're sort of developed a camp or a feeling where people who did Lisp programming would think, or did they think that they knew something that other people didn't? I don't know. I'll let them speak for themselves. But the other people started to regard Lisp programmers with a proper amount of suspicion, um, because it wasn't immediately obvious what they were trying to do, or what their programs didn't really make sense in the procedural paradigm. Uh, I'm kind of glazing over some people might say a lot. I'm glazing over some of the history here of computer science, but anyway, this is funny. Trust me. So, I mean, that kind of sets the tone a little bit for what we're going to do here. Anyway, Lisp, John McCarthy. How smart was John McCarthy? Well, he finished high school 2 years early, and he was so bored that he found college mathematics textbooks, taught himself how to do college math, and then when he finally got into college at Caltech, he already knew most of it and just skipped the first 2 years. He then got thrown out of Caltech, or suspended as the case may be, because he didn't want to go to gym class. Then he joined the Army. They readmitted him back into Caltech. He got his bachelor's degree. He met or attended a lecture there by John von Neumann, who's another important figure in computer science. Anyway, gets a PhD, goes to Princeton, as the case may be, and he does all sorts of other important work. Specifically, what we are interested in is what garbage collection is, which is initially which is why we sort of launched into this. We're talking about this guy. Is it funny? Well, can be. He didn't want to go to gym class. That's a little humorous. But there's a link in this article to garbage collection. So what is garbage collection? Well, I'm gonna close this. The last video we were messing around with the interpreter a bit, and we were seeing how we had a variable and we gave it a value, and then as soon as we assigned another value to that variable, the memory location for that variable, or the memory location for the value of that variable, would immediately change. We demonstrated that beyond any doubt. So it's a given. And we talked a little bit about, oh well, this is why it's happening, and the reference counting and stuff like that. In a more general sense, it was garbage collection. Garbage collection is just a way of basically programming languages, or environments that they operate in, provide a way of keeping track of who's using what, and then when nobody's using a particular piece of data anymore. It just deletes, garbage collects, destroys, whatever you want to say, that piece of data, or any variables that refer to that piece of data, things like that. It was invented by John McCarthy around 1959 to solve problems in Lisp. So we can see right here, garbage collection is generally or often portrayed as the opposite of manual memory management, which requires the programmer to specify which objects to deallocate and return to the memory system. This the second part of this sentence right here is what we are purposely avoiding by using Python as a dynamic language and sort of glazing over some of the details of memory management. We will eventually be forced, maybe into what all that means right there, but for the time being, we'll click on manual memory management. What is it? Well, it's the usage of manual instructions by the programmer to identify, deallocate unused objects, or garbage. We'll click on garbage. Well, I've never read this article before. What is garbage in computer science? Garbage in the context of computer science refers to objects, data, regions of memory, computer system, which will not be used in any future computation or by a program running on it. It's good enough for us. It's essentially what we just said. So if you want to jump more into what we said we weren't going to talk about in the last video, that's where you're going to start. You're going to read John McCarthy's whole Wikipedia page. Then you're going to go to manual memory management, or memory management as the case may be, or I forget what was the name of it. Manual memory management. And then if you read that whole article, then you can click on garbage or go back to garbage collection, and you can read this whole thing and all the subtlety that goes along with that. But we're not going to do any of that, but you could in your own time if you want. All right, so we're going to moving right along here. Let's fire up this game. We can do this to any application. I don't know, maybe we'll crash Notepad. Why not? That sounds like fun. We're going to crash Notepad. That's the quickest way to do this. Go to load game. Go to the bottom. Doesn't matter what game we load. So how are we going to crash this game? It's a release product. People or we would like to think that people take care when they're doing release products and stuff like that. So obviously they want to have internal sanity checks and things like that, so that the application's not going to fall prey to basic bugs and stuff like that. So how are we going to crash it? Well, everything we've been doing up till now is we've been searching for a value, and then we get a memory location, and then we start stuffing or poking memory related to that address. So how are we going to crash this? Well, we've already started up Cheat Engine. We've attached it to the process. Call one of the previous we could crash it right now with like 2 clicks of a mouse. We'll do that in a later video, but if we do that, we're not really going to understand what we're doing. In the previous video, so we'll do it sort of the hard way, or the manual way, as the case may be. In the previous video, you saw we were kind of talking about pointers and address. This is a memory location relative to Shadowrun.exe, and then we were clicking on pointer down here. We could just type in the name of the process. In Cheat Engine, it's just going to start digging through values. So what are we going to do? Well, we had specific values we were looking for. We're going to do a bit of a cliffhanger here. We're actually going to stop this and then re-record this in the next video, because we may or may not do this real quick, and we may want to do some explanation. And with only 80 seconds left, again, we'll come back, because I don't know if this is fun for you, but this is the kind of stuff that I enjoy knowing what's going on under the hood, and then when I can take that knowledge and apply it to do random goofy shit like crashing applications, that's when I really start to enjoy myself. But we'll get to that.